So, hi guys. So this is the second lesson for our Scala functional programming stuff. I just gonna take the final things for our for Scala, for Scala things that we have to keep in mind to start doing things in a real powerful way. So when I told you a quick review for case classes, that was the last thing that we took the last session, just for keep in mind. So on a case class, it's on a shorthand way to define a class. We have uh, this is an example for this class. So the idea with this is define objects or any kind of abstraction for our domains using a short syntax or a pretty compact syntax. We don't need to define any modifier for our arguments within our case classes because Scala uh, do this for us, which is nice. So for creating, as you remember, to create an instance, it's pretty similar to call a function. We just have to call the case class definition and pass the arguments. The parentheses always are required. That I think I forgot to mention that thing last session. And also, if as you remember, our stuff is focused on immutable stuff. That means we don't have any setter method here. It's not allow change our values when the program starts. That really probably doesn't make sense for you because always we have to change values and reassign. I think things like that, but functional stuff is not focused in that situation. So for resolve that thing, so we can the case class, the Scala includes the method copy in order to do that kind of things. This is an example, but you see, this is other instance for our full variable. That means it's not the same. So also the case classes has implemented the toString method that allows us give a pretty nice representation in our terminal or in our can you hear me? I see some lag. Okay.
Yes.
So we don't have to do any for show our objects in our terminal for now, which is nice. So for we don't have to deal anymore with this. So I think that's all for case classes. So keep in mind, just it's a quick review. Let's start to talk about objects. An object in Scala, it's basically a class with exactly one instance. In other words, it's on a singleton across the class. We have the keyword object. Can define object that way. Let's change the definition. We are able to create functions within our object. you remember, this is an interpolation. We don't need return keyword for functions. And this is a definition. We don't need to create a new object to use the functionality that we define within then, which is cool. It's pretty similar to statics in Java, static operations. Or, also, we have two ways to interact with our objects. One is this, using directly. Which is cool. Other is import our object. And now we have my function in this scope, which is other alternative. And we saw when we should use any of these later. So, do you have any question up to this moment?
Object, and just to make sure, object is a singleton, and once you define it, it's available globally. It's like a global like the global element in Node.js.
Could be pretty similar definition, but short answer is yeah. You only have one instance
Okay.
per object. Cool. So there is another concept in Scala related to object, is the companion objects. And a companion object is an object with the same name with a class. So let me check. Yeah. Thank you, Ray. For use our object, remember using the import or directly, but you have to include the scope wherever you find the object. Yeah, good point. Thank you. So, for instance, we have an case class timestamp. Definitions, and now we have an object with the same name. By default, Scala has the method apply. That's a kind of helper to create different constructors for this. This is an example. So, for instance, we have hours, an int, and seconds. Type for apply always will be the same definition. In our case, some time stamp. And the idea is in that way, hours. Here we go. That's the idea. This syntax in Scala is called application syntax. It's a Scala feature to use an object like a function, but we create a new instance for that. Probably we need to do this instead of case class. We should use an class because case class already has. We don't need the new keyword as you remember. Oh, we are able to um, sorry, I forgot that this is not accessible for the classes. In case class, you have this by default. Let's do all. Oh, this is pretty useful when we have to, um, define static methods. And the idea is, put this as depend of the our requirements. Probably if we have some constants, uh, uh, makes sense have within the object instead of the class to avoid to create a new class just for a variable. That kind of things is useful here, and we see later the other uh, cases that we are using or we are when makes sense that use. Sorry. So, do you have any questions at this moment regarding to objects?
No.
Apply is similar to constructor in other languages.
Yeah, correct. We are able to define multiple constructors using apply. But yeah, good question. So also we have this is all for objects. We also have a case object in Scala. Uh, Case object is just for define types usually, and it's pretty similar to case classes, but we don't have to uh, create. Scala doesn't create a bunch of methods within the object. So, for instance, we don't have the copy, for instance, because we don't have only this value. This is pretty useful when we modeling using abstract data types. I will told you the theory probably the next session, but that's the idea. In functional stuff, always remember the types really matter, really help you to do pretty powerful and, and cool programs. So this is all for case objects. And also we have traits in Scala. It's pretty similar to an interface from other languages, but it's not the same thing. So, for instance, in Java, I think the most uh, similar concept is functional interfaces. I think was introduced in Scala in Java 8, but the idea is in traits we are able to create definitions for our abstract methods and also include an implementation for other non-abstract methods, which is nice. I'm gonna try to show you this. There are other keywords that we have in Scala is sealed. That means we define our abstraction and we won't be able to extend that abstraction outside this file, the file when you define, I mean. I will show you uh, later in a real example. Here we are not able to show what's the reason for sealed. I'm going to show you a quick minute. So for now, this is an example for trade. That the idea is have a kind of polymorphic definition. I'm gonna use this stuff. Sometimes it's good practice. Mark your trade as sealed. That depends of the case. That's always will be good idea. So I will define a visitor for any website. It's like that. We have an ID. Mm, this is an example. So as you can see, we are able to define methods pretty abstract without implementation, and also we are able to make our definitions include this implementation. Sometimes is useful, but yeah, this an Scala feature. So for created uh, a particular implementation, we could do this. Also, case classes can have default values, which is cool. Oh, that's we see. Here, we mark this as sealed. That means it's in other scope, and we don't uh, are able to use extents. So for demonstration purpose, now we are able to introduce. That's the tricky for sealed. Only protect our implementation and try to avoid the other people do things that we don't want. It's pretty useful, pretty cool. For the equivalent for case classes might be final keyword. This avoid we don't extend our case class. That's other pretty useful, specifically when we modeling any domain. So it's pretty useful to protect our interpretation of the domains. As you can see, we can introduce other stuff different for our definition, which is cool. It's polymorphic stuff. As we see this, you have to provide the implementation for this. That's the error. So, so for created is as we are able to define the type as the abstraction. We are able to use the super type for our users, which is important for the next topic that I'm gonna show you. Just for now, I'm gonna create another user. So, you have any question up to this moment? Okay,
No, so far.
cool. So I created this definition just for showing the next topic quickly. This is pattern matching. And the idea for the pattern matching is a kind of extended if expression that allows evaluate an expression depending of the shape of the data. So the syntax is here, for instance, def what is the user. So we have this. We need an expression. In this case, is the variable visitor. As you remember, is abstract. It could be an user anonymous or a real user or singled out user. We need the keyword match, and we have uh, the the cases for this. We are able to this is the ID, and we can do this in order to just ignore the created stuff. That means that underscore in this case. So he we have this. Also we have an ID, an email, and we don't care about creation date. Close. So we have let's see. This one. The match say that it's an user, which is correct. And also we have this in a pretty compact way. As you see, we don't need a lot of code, which is cool. Yeah, you have questions at this moment?
No.
Cool. Other thing that we can use for pattern matching is uh, deconstruct our objects. So, for instance, we have this. This could be any variable that you want. This is completely possible. As you see, we deconstruct our object pretty easily, and we have these variables. This is other alternative to use pattern matching. This is useful when you use collections or things like that, but it's the same logic. Uh, Well, this is all that I have for you today. Is our tour for Scala language. I think that's all stuff that we need to start to introduce functional concepts and try to give you more confidence with the language when you start to see the other pretty cool stuff. Hopefully, uh, you will enjoy. I hope. Cross my fingers for that. Have any question or anything that you want to clarify or to talk a little bit more?
What you did, the last thing you did is similar to the structuring in JavaScript, right?
Yeah, it's pretty similar. Correct. Well, if you have any question, please let me know. My Slack is open for you. In that case, yeah, that's all for now. Thank you for watching. Yeah, see you the next session.
Thank you.
Cool.
Thank you. See you later.
See you. Care.
Thank you.
Thanks.
Thank you.